You're listening to a podcast from 702 and Cape Talk.
702 and Cape Talk.
The Naked Scientist.
Our lines are open for you, 021 446 0567 or 011 883 0702. Now I see Volkswagen in South Africa is to be investigated by the national regulator for compulsory specifications and some departments over as the emissions scandal continues to affect the company's global operation. A new CEO has been appointed after the old one said we screwed up. I mean, I just thought his attitude, he was so nonchalant about it, and now he's gone and they've been fined billions of rands. So the rule of law kicking in there. But Chris, this is no small matter. The VW emissions scandal, this is our science story for the week. Tell us about it.
I think this is probably a scandal of the century, actually. You know, one of the world's leading trusted car brands is found to be falsifying its emissions data and actually doing that in a very crafty and clever and underhand way. It wasn't just a question of one rogue person who just decided to provide a few dodgy figures. This was a systemic and systematic approach to fool the regulator. And it's a really interesting story, actually, really, how it came about, because it started in 2013. There's a body called the International Council on Clean Transportation. They're represented in a number of countries, and they just decided to start testing emissions on vehicles in the US. And initially, I'm told, they approached Volkswagen and said, well, can we have some of your cars to test? And the company declined. So they actually obtained vehicles independently, and they ran them on various road trips up to Seattle and back from California. You know, they gave them a pretty good testing. And what emerged is this very dramatic disparity between the emissions that are declared by the car when it is cold and when it's running on a rolling road test ramp, and when it's actually out on the open road. And what's critical is that the certain emissions from a diesel engine are known to be worse for your health than others. And so steps are being taken by regulators and also by engine manufacturers to limit those emissions. They're specifically particles and also nitrous oxides. Now, it turns out that what Volkswagen had done is to write into their car systems an algorithm, a software function, which could essentially tell when the car was either at startup or on a rolling road, allegedly, and it would tell the engine management system to change its behaviour in order to limit the emissions of harmful things. In other words, when it's on a test ramp and the steering wheel isn't moving, it's just pointing in a straight line and the throttle's open at a certain level continuously, that tells the car, hey, I'm on test here, better behave. It's a bit like the teacher in the classroom and all the kids behave. As soon as the teacher turns his back, kids start doing what they like. Same with the car engine. As soon as it was out on the open road, the profile of emissions changed dramatically, and it looks like it was actually an intentional move to deceive regulators and make the cars look like they were performing much better than they really were. The big question is, if this company, driven by reputation and everything else, were doing this, what else is out there?
Absolutely revolting. And to think that there was also the story with Hyundai and Kia last year. They were overstating the miles per gallon or of 1.2 million vehicles. But as you say, this is the biggest scandal yet. Now, Chris, we've had this question before, and the only reason I remember it is because when my then producer suggested we ask you this, I said, but that's not a science question. How can you ask something like that? And then your answer made me eat humble pie. Why do wires tangle?
Yes, it all comes down to the question of what we call entropy. And everything in the universe is trying to move towards a state of disorder. And if you think about a solid is lots of particles in a very organised manner. If you break that solid up, it turns into dust, which are particles in a less disorganised manner. You'll see things tend to wear down and spread themselves out. They don't spontaneously rearrange themselves into a highly ordered thing. They tend to move towards disorder. So everything in the universe happens because there's an increase in entropy, an increase in disorder. And this was the discovery of Boltzmann, who was an Austrian scientist, about 100 years ago or so. Now, any chemical process, any physical process can be explained on that basis. You've got to have an increase in entropy overall for something to happen. Now, if you think about your wire, when your wire is neatly coiled or it's in a nice straight line, that's highly ordered. Therefore, there's only one way for it to be highly ordered. There are a very large number of different possibilities of ways that you could arrange the wire so it was disordered. That's first point. So the wire is always trying to, in inverted commas, tangle itself up because there are more ways for it to be tangled than for it not to be tangled. The second thing comes down to how people actually coil up cables. If you think about it, when you take a cable, most people, if they think, well, I need to get this into my bag, I want it to be tidy, they will take the cable, assuming they're right-handed, in their right hand, they will hold out the fingers of their left hand, and then they just wrap the cable multiple times round and round and round their fingers. Now, if you actually watch what you're doing when you make that manoeuvre, you're actually putting a twist into the cable. You're turning the cable in your hand in order to make a circle. If you go from something straight to make a circle, it's got to be turning. And if it's turning in a series of sequential loops, you're adding loop on loop on loop. Now you've got a twist in the cable, so when it's left in your bag, it's going to feel intrinsically forces inside itself trying to sort out that twist, and it's going to tangle itself up. Also, when you've got lots of sequential loops like that, one loop can fall through the other loops, and then you get a knot. So there are so many ways that the cable can tangle up. It's a real surprise that it doesn't tangle more often. Now, nature has solved this problem because nature has exactly the same problem in every single one of the 100 trillion or so cells in our bodies. And that problem is that in each of your cells, which measure a fraction of a millimetre across, most of them, there is a nucleus which is an even tinier fraction of a millimetre across, and inside that nucleus is a long chain of DNA, 2 meters of DNA. How do you pack something 2 meters long into something which is a tiny fraction of a millimetre across? Well, the answer is you've got to spool it up and coil it up. And nature has come up with the equivalent of knitting wool spools that it winds DNA around to avoid that very problem.
Fascinating. Marjorie, good morning to you. Welcome.
Yes, good morning. Good morning, Chris. Good morning, Reedy.
Good morning, Marjorie.
Yes, I was just wondering, it's a question in connection with borehole water. Firstly, is it drinkable? And if so, must it be boiled?
Hi, Marjorie. It depends. Borehole water, assuming that there's nothing else in the borehole apart from water, is of course very safe, and people all over the world have been surviving on borehole water for thousands of years. The Aborigines in Australia managed to survive in one of the harshest terrains on Earth for 50,000 years by knowing where to go and dig little holes and make scrapes in order for water to come up through the ground. Because the ground has lots of layers of rocks, some of which are impervious to water, some of which are porous, and porous rocks sandwiched between two impervious rocks will carry water in there. It'll be water under pressure because it's coming from a mountain further up, so there's water pushing down into the porous rock, trying to push the water through. You sink a line into there, the water will emerge under pressure. The problem is if someone's come along and contaminated your bore, and that can happen for a variety of reasons. One reason is that there might be minerals in the rock that are not good for you, arsenic or something like that, heavy metals. The other possibility is when you live in the middle of nowhere and you dig a borehole, it's very hard for it to become contaminated. If you live near a very big urban settlement where there are drains and sewage and lots of people, then the groundwater can become contaminated with foul water, and this can find its way down into those of porous rock and contaminate the bore with sewage. So you have to be a little bit careful. I would recommend regular testing of water from a bore for things like microorganism load and therefore pathogens, but also other things, the trace elements and minerals in there, just to make sure. And if the water keeps turning up a clean bill of health, then it's not going to do you any harm whatsoever.
Right, let's take a break. We'll be back with more of your questions.
702 and Cape Talk.
The Naked Scientist.
Rian in Menlyn, good morning to you.
Hi, good day, Chris. Just want to find out if matter accrues mass at relativistic speed and our galaxy moves at around about 19% the speed of light, can that not account for a certain percentage of the dark matter in the universe for all galaxies? Because it's a lot of mass and it's a lot of speed.
Hello, interesting point. And yes, we are moving around the universe at some speed. I don't know what percentage of the speed of light that is. I'd have to do some calculations and check that. But here's my thought. You mentioned that the galaxy is moving and therefore the galaxy's mass would change. But actually, the reason that we know that dark matter must exist, and this is thanks to Zwicky, who first started looking at this question a number of years ago, the reason we know that dark matter must be there is that when you look at how, say, stars go round the centre of the galaxy, or planets go round our own star, they go round in a circle, and we understand that the gravity from the star is pulling the planet in, the gravity from the centre of the galaxy is pulling the stars in. There should be a certain speed at which those stars orbit the core of our galaxy. And if you look at the way that our stars are going around galaxies in our universe, they don't quite fit with that relationship. Something else must be there affecting the way the stars are moving. The only way we can resolve this at the moment is to account for the star's behaviour by modelling the presence of something which is very gravitationally active, is a big halo round the outside of our galaxy. And that is what we think is a dark matter halo. We call it dark matter because it doesn't seem to interact with anything and therefore it looks dark, but it's very massive and it exerts a big gravitational effect. And that would not be affected by the movement of our galaxy, because within our own galaxy, it's not moving relative to the things in our galaxy. So why would it therefore have any effect on the mass of the stars? On its mass and therefore on the behaviour of the stars. So we can't explain it entirely on the basis of what you've suggested, although it's a good idea.
Okay, Rian, are you happy?
Thank you.
Thank you.
Yes, thank you. I appreciate it.
Thank you so very much. Somebody has sent us a long email, but I think the crux of the question is, why doesn't sea water evaporate? Does it always stay the same throughout different temperatures? But yeah, okay, so that's the question, Chris.
Well, the answer is seawater is evaporating all the time. And every single part of the Earth's surface at some point is being illuminated by sunlight. On average, the amount of energy hitting the Earth's surface, every square metre, is about 1 kilowatt. That's the rate at which energy is arriving from the sun. Therefore, each square metre of the ocean surface is being heated at the rate of about 1 kilowatt. This means that with that level of energy input into the ocean, some of the particles of water are going to, by chance, have enough energy to evaporate. They'll break the bonds which are holding the water molecules to other water molecules, and this will enable the water molecules to escape into the air, and they will rise into the air as water vapour. As they rise, they will slowly expand, because vapours expand as the pressure drops because of warm air rising, and as they expand and the temperature drops, they will then condense and form droplets of water, and that's where clouds come from. As those clouds head towards the land, they will slowly accrue more and more water until in the end the water increases or exceeds the ability of the cloud to keep it up there, and the down pull of the raindrops will exceed the updraft in the cloud, and it starts to rain, and the water lands on the land. It dissolves through the soil, takes a few salts and things with it, ends up in a river, flows back to the sea. And that's the water cycle. So the water is continuously being evaporated from the ocean. The reason the sea is salty is because salts are carried off of the land when it rains. They're deposited in the ocean, but what evaporates from the sea is fresh water. That goes up into the clouds again. So slowly the oceans accrue more and more salts and minerals from the land until you reach a sort of steady state chemical equilibrium where, as you add more salt, other chemical reactions remove the extra salt, so the ocean stays about the same level of saltiness.
Is it Brian in Milnerton? Good morning to you, Brian.
Yes, hi. Chris, I'd like to ask you about the evolution. It made me think about it with Homo naledi. It seems to me that probably the most successful creature will survive. How come we have humans and we have monkeys? Surely whatever evolved from the monkeys were more successful than them, and they became more sophisticated. And we have none of those sophisticated creatures or hominoids that are alive. We've only got the unsophisticated apes and the sophisticated human beings. And we don't have any of the other ones in between, as I said, which were probably more successful or more sophisticated. We have none of those that are alive. All we do is find bones.
Hi, Brian. Well, the answer is nature has done experiments over many, many years as time's gone on to slowly arrive at a formula which is an individual or a group of organisms best adapted to their environment. Now, at the moment, humans are pretty successful. There's 7.5 billion of us nearly on Earth right now, and that's a big number. But at the same time, there are environments in which we are absolutely hopeless at surviving, and we wouldn't stand a chance in hell. But there are apes who would survive very well in those environments. In other words, it all comes down to where you live and what the pressures are from the environment to keep you alive and give you an advantage. And that's where the whole idea of survival of the fittest or evolution by natural selection comes from. Now, if you wound the clock back far enough to, say, 3.5 billion years ago, you would find that the only life on Earth was a bacterium. But the reality is that that bacterium evolved and ultimately became you. And the evidence for that is that that bacterium, the genetic code that runs in all of the bacteria on Earth today, is identical to the genetic code that's running in you and me and an ape and an apple and an orange, even today. And if I look at the number of genes in my body that are also present in a banana, there's about 60% overlap. So I share 60% of my genes with a banana.
No wonder I like
that
bananas
shows
so
that
much.
we all have common... Well, there you go, because you like me. That's the evidence that we all have common ancestors. We're all related to a common origin. And if you think about it like they say the tree of life, you've got the trunk of the tree and it branches. Well, along those branches, just because a branch branches out and you get different things coming at different places in the tree, it doesn't mean that all of the rest of the tree dies off just because one branch exists. The branches all continue to grow and produce new offshoots all over the place. And that's exactly how the tree of life and our evolution works.
Fascinating. Now, Janet wants to know, please ask the Naked Scientist how mountains were formed and how hot is it under the earth?
Well, the Earth actually is pretty big. The radius of the Earth is some 6,000 kilometres, so that's how much Earth there is under your feet right now before you get to about the centre of the Earth, or the core. And in that core, it's about 5,500, 6,000 Kelvin, so about 5,500 degrees centigrade. And the energy that's in there comes from a number of places. One of the places is that the Earth has radioactive elements in it, including potassium-40 and a number of other things. As they radioactively decay, they give off heat, and that heat is stuck inside the planet, so it keeps the planet hot, and that in turn produces convection currents of hot rock, magma, which try to rise because they're less dense towards the surface of the Earth. At the same time, you've got heavy stuff on the outside of the Earth, lighter stuff on the inside, and so under gravity, the heavy stuff's trying to fall inwards, the lighter stuff's trying to come upwards, there's friction there. All these things keep the Earth hot and keep these convection currents moving. If you've got convection currents and a liquid inside, you've got heavy stuff on the outside floating on the liquid inside like a boat floats on water. And that's the theory of plate tectonics. The surface of the Earth is broken up into these plates, which are big chunks of the Earth's crust. And because they're floating on this ocean called the mantle, then they're all sort of jostling and jockeying for position on the Earth's surface. We don't know exactly why they adopt the movements that they do, but you've got this sort of jigsaw puzzle all over the surface of the Earth. Some plates are trying to go one way, some are trying to go the other. Where they meet, you will end up with either one plate having to give way to the other one by sinking underneath it, or the alternative is that the two plates agree that they're going to have to compromise, no one is going to win, and they go upwards. And so they will have what's called a folding effect, and one plate pushes upwards, the other plate pushes upwards, and you get mountains. And that's exactly, for instance, where the Himalayas came from. About 100 million years ago, India was right down near Antarctica, and it has slowly migrated its way upwards and pushed the seafloor of the Indian Ocean up in front of it, and that seafloor was pushed out of the water and became the Himalayas, where India collided with Asia.
Let's go to Margaret in Bryanston. Good morning.
Morning to both of you. I'd like to find out, please, Chris, how safe are the non-stick linings that coat baking and frying pans, please?
What's in them? I'd like to know, Margaret in Bryanston. Chris?
Well, these are fluorinated chemicals. Teflon is the trademark name. And these chemicals are very good because they are very unreactive and they have strong bonds that hold them together. And they form very weak interactions with things like water. And so that's why water tends to bead on the surface, because it's not sticky. It's a bit like trying to make oil and water mix. The two things don't want to talk to each other. And this helps to give them their non-stick property. When it's stuck on the pan, these things are absolutely terrific. The problem is that when they come off of the pan, which they do with time and wear and repeated cycles of heating and cooling and therefore expansion and contraction of the metal in the tin, they slowly come off. That begs the question then, well, actually, I'm not allowed to say begs the question because that's grammatically incorrect, I'm told. This means there is an issue about where those things go and what they do to us. Now, because they're fairly unreactive, people are relatively comfortable that they probably don't do much in your body. But there is some evidence that they do accumulate in the body. There is some evidence they may have an effect on our metabolism. There's certainly evidence that they're building up in the environment. And scientists have been down to Antarctica and they have studied the middens left behind by penguins, because penguins go fishing. The fish which live in the ocean, a lot of this stuff washes into the ocean. Fish will accumulate these things. The penguins eat the fish, and therefore they accumulate what the fish has accumulated. And when penguins poo and die, and they therefore contribute to these middens of penguin poo and dead corpses of penguins, they leave behind any chemicals they've built up in their bodies. And you can detect quite a few of these chemicals down there. And because they are unnatural chemicals, you don't find these sorts of chemical bonds in nature. Nature doesn't really have a mechanism for breaking down those chemicals naturally. That's why things like plastic bioaccumulate. You can't get rid of them because they're unusual forms of chemistry which give them the exciting properties that they have. But at the same time, because they haven't existed in nature previously, nature doesn't have a way of degrading them. So they're building up. What the consequence of that may be, well, at the moment, scientists are doing tests to see exactly what they do to the body and how they might affect things. But the answer is we don't know. The risk is probably small, but it's probably not zero either.
Thank you so much, Chris. Have a lovely weekend. Ta-ta.
I will try my best. Thanks, Reedy.
Bye-bye.